Hello, and this is the DRSS Digital Electronics class. Today we're going to be going over an intro to Arduino and programming it. My name is Mark.
I'm Ryan. I'm Ben.
I'm Orlando.
And I'm Noah.
So first off, what is Arduino? Arduino is a programmable microcontroller, and it's got 14 I/O pins, a USB Type B adapter, and needs to have a constant power source. It is programmable in a C-like language, which we will be going over later.
Alright, so the point of us using the Arduino is so that we can hook up sensors, but instead of buying a sensor kit, we think it will be better to buy those sensors individually because it will end up being cheaper in the long run because we won't have to buy the stuff that we already have and we won't have to buy the sensors that we don't want. But past all the sensors, we will also need to have resistors, capacitors, diodes, and soldering equipment, most of which we already have. And then with our Arduino board we are looking at using, we'll only be able to use 1 or 2 sensors at a time because of limited space and power from the board. And then to keep information from our sensors and our flights, we will be attaching a SD card reader so that we can read the data after our flight. And then before we attach the Arduino board to the quadcopters, we will want to breadboard all the sensors to make sure everything works properly.
So, like I said earlier, the Arduino is programmed in a modified C language. It's a microcontroller, so you can control the output from the pins, making them high or low. Some of the basic functions are pin mode, that sets the mode of the pin to either input or output. Digital write and digital read, either output a high or low signal or read in a high or low signal from a pin. And then analog write and analog read output a PWM signal to a pin. So it's not actually analog, it just modifies the duty cycle of a square wave. Some basic C flow control. This is an if statement. It changes what code executes based on some Boolean expression. This is a switch. It changes which code executes based on some value, some variable. Then there's for loops, while loops, functions. It's too much to cover in a minute, so that's some resources and references for C and for Arduino.
So a few problems that we see with Arduino Uno or 3 is that the few input-output pins were limited to 14, and the SD card reader itself takes up 4. So we're only going to be able to attach 1 or 2 sensors per quadcopter or Arduino unit for testing. So like I said, the SD card slot will take up majority of the pins available, and it needs an external power source, which could be derived from the quadcopter battery itself, but then that also takes away the flight time from the quadcopter, and if we use an external battery for it, it also adds weight to the quadcopter, which lowers the flight time as well.
There are a few viable alternative solutions to using our Arduino board and our quadcopter. We can use either a Raspberry Pi Zero microcontroller board or one of the various Atmel AVR microcontroller chips. The benefits of having a Raspberry Pi Zero is it's lower weight, it's more powerful with a higher clocked core, it's more compact, and has a lot more I/O than the Arduino has. The problems is you have a full-fledged Linux OS on the Raspberry Pi that you have lots of overhead you need to deal with, and you'll have to teach new students how to use a Linux-based OS before allowing them to program. The benefits of a Atmel AVR is it's very lightweight compared to a Arduino or Raspberry Pi being just a single microcontroller. And it's the exact same processor that Arduino uses on the board. Only problem is some require an ISP to program, which is image signal process,
In-system programmer.
what?
In-system programmer.
In-system programmer. In-system programmer to program, so you'll have to code it separately, put it into the little thing to program it. I need to bring that to you stuff up. Anyway, and then some will also require an external crystal clock to run, so it doesn't have any timing circuitry on board, and everything will be very low level compared to an Arduino.